Hey everyone, in this video we'll be looking over question 124, binary tree maximum path sum on Leetcode. This is part of our Blind 75 playlist on Leetcode where we go through the Blind 75 questions. So let's begin. Now you notice this question is actually hard, but in my opinion it's actually not that hard once you've learned the trick. If you've done the maximum depth of a binary tree like we've done here, we're actually going to be following the same exact procedure. So it's actually not as hard as it seems, but a good problem nonetheless. Let's begin. In this problem, a path in a binary tree is a sequence of nodes which are basically joined together like this with the edge. And essentially what we want to do is we want to find the path sum, which is the maximum one. And importantly, it doesn't have to pass through the root. So what I mean here is the maximum path sum here would be 2, 1, and 3, which would give us the value of 6. The maximum path sum here would be 15, 20, and 7, which would give us the value of 42. Note that it doesn't have to pass through 10. We're not asking to find from like maximum path from like left hand side, right hand side, passing through the root. Here it actually doesn't have to pass through the root, so it can be any path in the binary tree. So that's the difference here. So you might not know how to start this, but as with any binary tree question, kind of the format I like to follow, whenever it asks for a maximum or a minimum or min distance, max distance, something like that, the approach I like to follow is I like to have a variable which I will call my result variable, and I'll set it equal to 0. And then I like to do my recursive call, in which what we do is we go through the binary tree and we try to find potential answers to the question. And if the answer is better than the global answer, then we will update the global answer. Otherwise, we'll just keep going, we'll just keep recursing. And then in the end, we just return self.res. We return the global answer. So this is the exact same format I kind of followed over here. So you can follow it here as well. Now, in this case, always for the binary tree questions, I like to start off with the basic cases. So let's say the root does not exist. So what is the answer in here? Well, I actually don't think we need to worry about the case where root does not exist, simply because we have negative values here. So it doesn't even make sense to return 0, because that could potentially be an answer. So I don't think we need to consider the case where root does not exist. So we can just have like this kind of format over here. And given that we have like negative values in the root, and we're taking the maximum, it might make sense to put this as like negative infinity. And so like every time we take the maximum, it'll be maximum of the smallest number. So we'll take that one. So let's take a look at like how we can do this. And all we need to pass in, and again, this is like pretty much exactly the same as how we did this. So we'll pass in the self, we'll pass in root. And so let's take a look at some simple cases, right? So again, we don't need to consider the case where root does not exist, but actually if we do that here, right? So let's just say if root does not exist, then the maximum path, if the root does not exist, let's just keep it as 0. Because if you think about it, 0 and then added with any number is just going to be that number, right? So we can just keep 0 over here. What about the case where root does not have a left child and it does not have a right child? So it's basically like a leaf, so and not root.right. If this is the case, so something like 7, and you can see like we do the same exact thing here. So if it's something like this, then what we want to do is we want to return basically just the root's value, right? Because this is the maximum path you can form, just the 7 itself. So that's what we have over here. And one more thing we want to do is whenever we do a return statement, we want to update our result variable, our global result variable. So because that could potentially be the correct answer. Now, otherwise, what do we want to do? Well, otherwise, you can kind of think of, let's actually grab this inside Paint and kind of take a look at this. Oh, that was terrible pasting. Let's take a look at like how this can actually work out. Something like this, right? So let's say we're on 20 over here, right? We're on the 20, and we want to look at the left child and we want to look at the right child, right? Now, in this question, it's not necessary that the path, the maximum path, pass through the root. What is the root? The root in this position will be 20. So it's not mandatory that the maximum path actually pass through the root. In fact, I can think of a couple of maximum paths there can be. Well, there could be a maximum path from the left-hand side. So maybe something like this would be a maximum path from 15, like the maximum path of the left plus 20. I can think of another maximum path would be maybe something like right-hand side plus 20, right? What's another maximum path? Well, what if what if I want to consider 20, right? What if I want to consider 20? Like, what if I want to consider something like this, right? Would this be a maximum path? Sure, this can also be a maximum path, right? Now, what about the case where if I do this, it actually ends up causing a smaller number than I needed? So for example, let's say this left-hand side over here, I'm looking for my text. Let's say this left-hand side over here gives me something like -5, and this gives me something like -10. Well, in this case, do I really need to take the maximum path? Well, no, the maximum path here would just be 20, right? It wouldn't be left-hand side plus right-hand side. It wouldn't be left-hand plus root. It wouldn't be right-hand side plus root. It would just be 20 itself. So those are just like some different cases that we might want to consider here. So let's kind of just write this in code and we'll see how it goes. And we can refer back to this picture just to kind of get an idea of how this should work. But what are some of the maximum paths that we need? So one thing that we always want to do in these types of binary questions is recurse to the left and recurse to the right. So let's just do that. So we'll recurse to the left and then we'll recurse to the right. All right. Now, what do we have now? So now we have the answers, right? We have the answer of the maximum path to the left-hand side. We have the answer to the maximum path to the right-hand side. Now, what are some potential paths that we can take? Well, one potential path is we can take the left-hand side plus the root plus the right-hand side. So that is path 1, which is left plus root.val plus right. That is one potential path. What is another potential path? Another potential path is what if the left-hand side is something like 50, right? Like let's say it's something like 50, right? Then 50 plus 20 will obviously be more than 20 plus whatever, like -10, right? So in this case, we'll just take the left-hand side. What if in the other case, the right-hand side is also actually bigger than the left-hand side? Well, and the left-hand side is negative. If this is like swapped, then it would make sense to just take the right-hand side. So in this case, a second path can be, we'll take the maximum of left and right, and then we'll add it to the root, right? So that can be another path where we take the maximum of the left and the right one. So let's say like these two were both positive. So I'll remove this and I'll remove this. So if both of these were positive, right? Like if we had a case where like this was like 5 and this was something like 10, right? Then the best path would be considering everything. But if we had a case where this was something like 5 and this was something like -3, well then we can just consider 15 and then 20, the left-hand side, and then the root. We don't need to consider the right-hand side. Similarly, if this was like -5 and this was like 3, then we just need to consider the root and the right-hand side. We don't need to consider the left-hand side because that would basically minus the answer. It would make it less. So the first path is when all of them are positive and actually taking the root will be benefit to us. The second path is we take the maximum of the left child and the right child and we include that in our root. What about the third path? Well, in the third path, what if both of these numbers are negative? Well, in this case, we don't actually want to take any of these paths, right? We don't want to take the left child, we don't want to take the right child, because both of them will be a smaller number. In this case, we'll just actually take the root, because the root itself is the maximum path that you can form up till this point. So we'll just be root.val. So now we have 3 paths, right? And so what we can basically do here is we will update our result variable with maximum of path 1, path 2, and path 3. Now that we have that, well, consider where this is being called from, right? This 20 call is being called from this 10 over here. So what I want to return to this 10 is the maximum that I can get from this 20 call over here, like the right-hand child. It would be incorrect for me to return self.res. This is not correct. We never return self.res. We only return self.res from the main function. From the helper function, we're only returning what the parent is expecting. The parent, -10, is expecting the maximum path I can form from the right-hand child, which is 20. It's completely possible that self.res is actually formed completely on the left-hand side. So it's not correct to return that. From the right-hand side or from the left-hand side, when you're being called by a parent, you only return the answer that you have so far that makes sense for you. You do not return the self.res. So this is basically the function in itself then. Over here, we just call it with root. And let's just go ahead and check it out. And we can see we get exactly what we wanted. Let's go ahead and submit this. and we get the wrong answer. And let me see if I made an error actually with any of these. So path 1, path 2, path 3, float negative infinity. So path 1 is left-hand side plus root plus right. That's correct. Other path is maximum of left and right plus root of val. Path 3 is just root of val. So I believe that should be correct. Let me see if I made a mistake anywhere here. And I returned self.res. That was the mistake, right? So I actually need to return the maximum of all three of these paths, which is path 1, path 2, and path 3. So I need to return the best path so far to the parent, and it is returning an error. So one more thing I need to mention is if we are considering from the -10, right? If we are considering from -10, it would be incorrect for me to return a path that does not include the root, because I can't go from like -10, like this would be wrong. I can't go from like -10 and then straight to like the left-hand side path over here. This would be incorrect because I need it to be connected to 20, right? I need to be connected to 20. So basically, what am I returning to the parent? I'm returning the best path in which it actually takes the parent into consideration. So in this case, what I would actually be returning is path number 2 or path number 3 because that also considers the parent. So I will do something like this, path 2, path 3. And there you have it. That's the answer. So let me just explain this final part again, because I think that one might have not been too clear. But basically, I want to summarize this in just a few steps. So in function, basically what we want to do, calculate self.res with all potential paths, right? All potential paths. So all potential paths could be just a parent in itself, left-hand side plus parent plus right-hand side, or maximum of left and right plus the parent. Otherwise, when returning caller, return the path, the best path that includes the parent. So in this case, when you're returning to the -10, we will include the path that includes the 20. If that is potentially with the left-hand side or with the right-hand side or with just the 20 in itself, you'll return that. But it has to include the 20. Because if you think about it logically, like what this is saying, this is basically saying that give me the best path so that it goes through 20 and potentially goes to the left-hand side children or potentially goes to the right-hand side children or just stays at 20 itself. So it would actually be incorrect here for us to return path 1, path 2, and path 3 because if I was to do that, then potentially what I would return here is something like this, which is not correct. So that's this question. It takes a little while to kind of just wrap your head around that you might have to consider multiple paths, but if you just follow this sort of structure, in that if you're finding maximum minimum and you keep some sort of variable to do that and you update it whenever you need to, and when you're returning, you return the path in which you always take the parent node. So maybe to kind of make this more obvious, this is the path in which like you take parent. This is also take parent and both child, take parent and one child, right? And so what we're returning, and this is just take parent alone, right? So what we are returning is we're returning take parent alone or take parent and one child. We can't obviously take two child because that wouldn't be a valid like at sum. Okay, this was this question. So it was a bit long, but hopefully you got the idea. And I'll see you in the next video.